Hello and welcome. In this tutorial, I will demonstrate how to run and interpret a Pearson correlation in SPSS. Also, I will show you how to construct a scatterplot with a regression line to visualize the correlational relationship. If you are following along for the tutorial, please download and open the Stressful Events in Psychological Health dataset in SPSS. In this example, we will be examining the relationship between the number of stressful events experienced by college students and their psychological health. Imagine we had 25 college students fill out a stressful event checklist that had them mark how many stressful events they recently experienced out of a total of 82 different events. We also administered them a 7-question psychological health screener and created an overall psychological health score out of 35, with higher scores indicating better overall psychological health. As we move over to the dataset and take a look at the variables included, you'll notice that in addition to our 2 variables that are of interest to examine the relationship between stressful events and student psychological health scores, there are a couple other variables that are included here. And these variables were thought to be related to the number of stressful events as well. So in particular, we have a happiness score, which higher values here represent higher kind of subjective happiness for participants. And we would anticipate that as students experience more stressful events, we might predict that their happiness score declines. So we might predict a negative association between those 2 variables. Also, we included a rating of negative affect, which we maybe would expect that as students experience more stressful events, that this would be positively related to their negative affect or kind of a negative mood overall. So more stressful events would have higher negative affect ratings. So this just allows us to maybe see a couple of more diverse examples of correlation and how flexible the correlation dialog box in SPSS is to allow us to look at multiple relationships, and also allows us an opportunity to interpret some different types of relationships, be it in direction as well as whether or not they're significant. So again, if we want to look a little bit closer at the variables, we can switch over to variable view and see kind of the descriptions of those variables. We also have a nominal ID variable just to code which participant is which. So for now, let's keep things simple and focus just on the relationship between this number of stressful events students experienced and their psychological health score, kind of that original hypothesis we had. So we want to evaluate this with a Pearson's correlation coefficient, or a Pearson's R, because both of these are quantitative measures on either interval ratio scale of measurement, making the Pearson correlation appropriate for these 2 measures. So how we would go about running a correlation is we would go to Analyze, and as we scroll down the list of menu options in the drop-down menu, we come across Correlate. And here's our correlation options. And within there's different options. So the standard one is to do a bivariate correlation, which means we're looking at the relationship between 2 variables. But you can see other options, like if you wanted to do a partial correlation, which is looking at the relationship between 2 variables while controlling for a 3rd variable, we would use this drop-down menu option there. There's some other ones here that are beyond the scope of this course, but we'll focus primarily on running a bivariate Pearson correlation here. So go ahead and click bivariate, and this will bring up that dialog box here, and we see on the left our 4 variables of number of stressful events, psychological health score, happiness score, and kind of negative affect rating. And for now, we just want to focus on the relationship or the correlation between number of stressful events and psychological health to kind of keep our output and interpretation simple. You'll see that SPSS has a bunch of kind of default menu options clicked, and by default, SPSS runs a Pearson correlation looking at 2-tailed significance. However, we have the opportunity to change this based on what we're looking at. So we could request in addition to Pearson R, a few different correlation coefficients like Kendall's tau, which is a non-parametric correlation, or if we had ordinal data, or we're looking at a directional but non-linear relationship, or we might check off to run the Spearman's correlation. But for now, again, just to keep things simple, we're going to do look at the Pearson, which is the appropriate measure for our appropriate correlation statistic for our two variables here, and do the default two-tailed because we want to see, regardless of direction, if it's a significant positive or negative correlation. Finally, SPSS has a default of flagging significant correlations, which we want to keep. It's very helpful for identifying when correlations are significant or not. Before we run it, we can look at the list of options, and here you see that the list of menu options is somewhat simple in what you can request. So if we wanted for each individual measure included in our correlation analyses, if we wanted to get their means and standard deviations, we could request those descriptive statistics. Also, we could look at the kind of measures that are used to calculate the Pearson's R, such as the cross-product deviations and covariances. So these are a measure of variability with considering the two variables together. However, again, just to keep interpretation simple, we're not going to request either of these and just focus on the correlation Pearson R that we obtain when running the analysis. So once we have this all specified in our menu options and under bivariate correlations, we can go ahead and click OK. And this will generate that output here. And importantly, when you see this output, you can go ahead and double click if you wanted to edit this table in any way. If it was easier to delete a column, you could do that. And what you see here is that SPSS lists our variables in order in which we specified them in our dialog box, with stressful events first and psychological health second. And what we're interested in is this Pearson's R statistic right here and its significance. So what we see first and foremost is that the correlation coefficient, or Pearson's R, was between the number of stressful events and psychological health was negative 0.530. And the two asterisks here let us know that this correlation is significant at the 0.01 level. We can also interpret the two-tailed significance here to see that the exact probability of obtaining a correlation this large of 0.53 or negative 0.530 when there really is no correlation in the population is p equals 0.006. So very low probability that we're seeing this relationship in air. And we see it also provides us our sample size or number of participants included in this correlational analysis. So from this, what we could conclude is that our correlation is negative, as we see here, negative 0.53, and it is significant at p equals 0.006. So this would lead us to reject the null hypothesis and conclude that there is a relationship between the number of stressful events and overall ratings of psychological health. In particular, students who experienced more stressful events actually had lower overall scores of psychological health, and that's where the negative relationship comes in. Next, we're going to take a look at if we wanted to visualize this relationship in a graph or figure, with the most appropriate graph for correlational data being a scatter plot. So if we go back to our data set here, and this time go to the graphs menu and use SPSS chart builder, we're going to construct a simple scatter plot to kind of help us visualize this relationship or what it looks like for an R of negative 0.53 for our 25 participants on the number of stressful events and their psychological health scores. So go to graphs, chart builder, and we'll get this extra pop-up box here, and you can go ahead and just click OK to get into the chart editor or chart builder menu. And here again we can see our options of charts available to us, and for correlational data, a scatter plot or a scatter dot graph is the easiest way to kind of visualize and see that relationship. And there's a bunch of different options here. We can choose to do a scatter plot of just a simple bivariate relationship, which is what we're going to do here. But you can also do a look at multiple bivariate relationships between different categories using a group scatter, or three-dimensional relationships by looking at three variables in three-dimensional space at the same time. For now, we're going to just do the simple scatter plot and go ahead and drag and drop that into our chart preview up here in order to allow us to do this. And what we want to do is visualize that negative relationship between stressful events and psychological health. So what we would do is, since stressful events is thought to be kind of our predictor variable, this would most likely be the variable we would want to put in the x-axis. This is what we're thinking of as our x variable or predictor variable. Then our y variable, our outcome variable, would most likely be psychological health. So we would put that in the y-axis here. From there, there's not as many options available maybe as, say, looking at means where we could put standard error bars. And some of the options available to us we can actually apply after generating and making the chart. So for now, we're just going to request this scatter plot that looks like this. If you want to go ahead and click OK to generate the scatter plot graph into our output, we can go ahead and do that. And here you see kind of the default settings for requesting that. And again, we see some kind of peculiar things that we can change by going into the graph editor, but we definitely can visualize that negative relationship. If we kind of draw around it here in envelope, we see that while there's some inconsistency in that predictive nature, there definitely is a negative or downward trend that as undergraduate stress scores or scores on the undergraduate stress questionnaire, the number of stressful events increases, psychological health score out of 35 decreases. So let's double click on this to show you some ways in which you might think about editing this scatter plot to make it kind of more presentational. So what we might do is, if we wanted to, we could change the axes. So one thing that I noticed right away is this score here could be better represented if we kind of put the full range of psychological health score measures on here. So what we might do is click on the y-axis here and go ahead and go to, we'd want to go to scale. And we can go ahead and adjust this ourselves. So the lowest a psychological health score could be was actually 7. So we're going to go ahead and put 5 so we could keep it in nice increments of 5 on our y-axis. And click apply. And now that helps us kind of see the full range of that scale and where our data points fall. We can also choose, if we wanted to make, change the axis labels. So maybe we just want to keep this simple and go psychological health score. And we can make this bigger if we wanted to. So there's a lot of options available to you. And again, maybe it's more intuitive to change our x-axis label to number of stressful events. And just like we did with our y-axis, probably represent the full range of possible options on this. So if we go to scale here, we know that students could put up to 82. So maybe we'll just, since there's no one at that extreme, maybe we'll just put 80 for here and keep it at an increment of 10 and go ahead and apply that. And then we can kind of see again that full range of the construct. I like here as well to keep it at maybe increments of 10 within our x-axis plotting, and we can adjust the size as well of that label to clean this up any way we would want. So that's the first step. We can also clean this up in other ways. So if you double click here and bring up the chart editor for our kind of overall chart preview, we can change the fill here. So if we didn't want it to be a gray background and wanted it white, we could do that. If you wanted to change kind of how our scatter dots look, we could do that by making them maybe slightly bigger, changing their color and applying that as well. So right now that's their border, but maybe I would want, say, a gray border and a yellow fill to apply those there, and it would look like that. So you can clean this up using a lot of the chart editor functions in a way that looks much more presentable if you were to actually put it in, say, a research report. Generally, if we were to transition this to a research report, we want to keep it in black and white or grayscale overall. Another helpful thing within the chart editor options in this dialog box is we can enter or include the regression line or the line of best fit between our data, which then also automatically generates the coefficient of determination, or the R-squared. We can do this by going into Elements, so the Elements drop-down menu here, and go Fit Line at Total. And what this does is provides the line of best fit, or the regression line of our data. And you can actually see the regression line here in such that the predicted Y value equals 33.09 minus so that would be our Y-intercept, and then 0.19 times X would be our slope, or so negative 0.19 times an X value would be our slope if we wanted to predict what the Y value would be. We also can note here that we have our R-squared linear, which is the coefficient of determination, and this tells us that 28% of the variability in number of stressful events is kind of related to is explained along with the psychological health score. So once we have all of that, we have a line of best fit. Keep in mind you can always adjust these how you see fit. If you wanted the line to be a little more prominent, we can make that bigger as well. There's a lot of options available to you. If you wanted to say, move it around in some ways, like bring it behind the data points, we could do that too, so that the data points are in front of it. There's a lot of options for cleaning up and making it look how you want. So let's go ahead and click out of here, and once we click out of it, you'll see our change is reflected in our output here. And so that's how we go about generating a scatter plot, and this really just helps us visualize what we found with our correlation coefficient. Lastly, we're going to look at kind of the flexible options available in requesting correlations and interpret a few more kind of correlations. So this was kind of the goal of including a couple more variables within our data set here, is just to show you how easy it is to request multiple correlations just in kind of one analysis. So if we go to Analyze, Correlate, Bivariate, what you'll notice is that we could go ahead and include all of our variables right within the variable data set. And what this does is SPSS will now generate correlations looking at the different combinations of relationships between all of these variables. So we'll be able to see the correlations or Pearson's R between stressful events and psychological health, as well as stressful events and happiness score and negative affect. But also it'll give us correlations between psychological health and happiness score, psychological health and negative affect. So all possible bivariate combinations of relationships will be examined. So if we go ahead and put all 4 variables in and go ahead and click OK, we can see how SPSS reports this within a correlation matrix. And this is kind of a good example of how we can go about looking at this and reporting different relationships. So our original relationship of number of stressful events and overall psychological health, we did find a significant negative relationship between these 2 variables. When we move over to look at the relationship between number of stressful events and happiness score, we again see a negative relationship between the 2, but notice the difference in magnitude of correlation coefficient. This is definitely not as strong as a relationship with psychological health. So while it does appear that there's some small association between increase in stressful events being associated with lower happiness, this was not at all significant. So P is much greater than 0.05, and again, we don't see an asterisk here flagging this. So we don't have enough evidence here to conclude that there is a relationship between stressful events and happiness score. And overall, if we were to look at the measure as a measure of effect size and calculate the coefficient of determination, in this case, we would see that the effect size is just above a small effect for a relationship. So in order to see a significant correlation in this case, our sample size would have to be much greater, and that correlation of negative 0.16 or negative 0.17 would have to remain consistent as our sample size increased. As we move over to negative affect, here we see a positive correlation, as we might have predicted, of 0.31. And here the effect size, or the size of this correlation, is greater than the happiness score. And we're actually right around a moderate correlation between stressful events and negative affect. However, with our sample size of only 25 participants, we cannot say or cannot conclude that there's a significant relationship between the two. What this would lead me to believe, looking at the data here, is that it does appear that there is a trend of a relationship given the moderate size of the correlation, and that we would probably need a larger sample size, or to run the study again with a larger sample of participants, probably around 50 or so, to detect this as a significant correlation. So that's why it's helpful to look at it both as the magnitude and kind of size of the correlation, in addition to just assessing whether or not a correlation is statistically significant. Also, if we were interested, we could look at all the other different associations between how psychological health might be related to happiness. Here we see a strong positive correlation between the two, or negative affect, as well as happiness score and negative affect as well. Finally, we could take a look at an example of how we would go about reporting these results of these correlations in an APA-style results section. So if I were to report these results focusing primarily on that original hypothesized relationship between stressful events and psychological health, it might look something like this. So a Pearson's correlation was used to examine the hypothesized relationship between the number of stressful events and the psychological health in a sample of 25 college students. As hypothesized, the findings showed that experiencing more stressful events was associated with decreased psychological health. And here we report the correlation coefficient of Pearson's R. So R equals negative 0.53. Probability is 0.006, and we conducted a two-tailed test. Importantly, we want to make sure we don't overstep our bounds in drawing conclusions. So it would be wrong to suggest that stressful events were the reasons that psychological health declined, since we cannot imply causation from a correlational research design and analysis. It's also appropriate to then report the coefficient of determination as a measure of effect size. So the coefficient of determination was R squared equal to 0.28, which represents a strong relationship, and we would interpret this as that it indicates the number of stressful events experienced shared 28% of the variability with psychological health scores. In some cases, you might see this reported as the amount of variability in psychological health scores was explained by number of stressful events. This is somewhat problematic because it implies that the number of stressful events kind of, again, was the reason we saw that change in psychological health, and all we can really determine is that they're related or have overlapping variability. As shown in Table 1, additional correlations between stressful events, psychological health, subjective happiness, and negative affect were explored. So when we're reporting multiple correlations, it's typically conventional to report these in a table called a correlation matrix, and it might look something like this. So here we list all of our variables and kind of go across the row, much like was presented in SPSS, to present those correlations. And just like SPSS does, an easy way to signify if they were significant and at which level they were significant is to put asterisks, letting the reader know which correlations we found to be significant. From there, you don't actually then have to report it within your results or within the text, but you can then just talk to it and refer people to the table. So findings showed that the number of stressful events was not significantly correlated with measures of subjective happiness or negative affect. But we might read a little bit more into the correlation with negative affect, because the correlation coefficient between stressful events and negative affect was moderate in strength, which would suggest that stressful events might be related to negative affect if we were to examine these variables again in a larger sample of college students. Finally, if you would like more help with correlation in SPSS, you can go to the Help drop-down menu and click Topics. From there, you can bring up the list of topics and go to statistics-based options. There you'll see menus for both bivariate correlations as well as partial correlations. Clicking on bivariate correlations, SPSS will kind of give you an overview and some tips within SPSS for conducting bivariate correlations. That concludes our tutorial.